Looks like we've got a stream on our hands here. Everything appears to be working. Okay. So, there might also be some background noise though, but we'll just deal with it. So today, I need to work on, the batch edit, and the replace range turned out to be a fairly complex beast on its own. But luckily, batch edits, I'm not going to make too hard on myself. If I take a look at how I did it in the gap buffer, I believe I have a sort of generic batch edit that I'm just copy pasting for now for each one, and then I'm going to potentially optimize each batch edit later. So the batch edit looks like this. I need a not there. Buffer batch state, multi-gap buffer, the buffer edit, pointer. This is kind of an unruly long signature, so right there maybe. Sorted edit, boom. Okay. Looks like that's about as good as that will get. And then let me see if all of this makes sense. I take I is less than edit count plus I plus edit. Do the replace range for the first edit you look at. That's pretty good. If resolved, shift total plus equal shift amount. Saves that so it can continue where it left off. Here, so we return. Yeah, so this looks like it might just work. I think that this is kind of like a generic. This is sort of a generic function that is. Just based on the base replace range being applied multiple times, and like for this one there's not really anything better I could do much better. I mean you could conceive of doing this better maybe, but this one I can almost certainly do better, but I just want it to work for now so that I can make sure everybody works, and then I'll spend a little bit of time optimizing each one to see how good they can get. But I don't want to go crazy with that yet, so hopefully this just means that the multi-gap buffer is actually done. We'll take a look. In order to find out, I have to find all the spots where I'm still not allowing this to apply. Okay, let's see if that works. Bada boom, it works. Okay, nice. Then there's also the main one here. Top, please. Okay, nothing in here. Okay, so that might be it. That might be it for the multi-gap buffer. Control Shift tilde. Alright, so that didn't work, which means that we're not done yet. Whoops, not continue, that doesn't do any good. Clean white space, break. Okay, so here it is doing an edit step. How many edits has it applied? 37 edits so far. It's going to apply this edit. And what went wrong? Size 2, 39, interesting. So it definitely isn't adding up as it says it's not. I'm not sure why I spent so much time verifying that it was correct. But what I have verified is that size 1 is too big. So we're doing a length 0 insert, it looks like. Yes. Why would that be there? What are you pointing at, actually? This part here, the sorted edits are correct for the other setup, so I'm not sure that this would be any different, like it shouldn't be wrong, but string start 24, length 0. Alright, so this is clearing out some unwanted extra white space, basically. That's deleting some white space. It starts at 12,283, which seems perfectly reasonable, and goes to 12,299. So it's basically replacing this range with the empty string so that there's no unwanted space there. So, what went wrong in here? The original size was 3964. It's hard to say for sure. 3959. Where is the start of this whole 3964, 3959? So it looks like maybe it didn't compute size 2 correctly. Maybe. It shouldn't have cleared it out to 0, for example. Or, no, that doesn't make sense, because we're adding up to too much, not to too little, right? So if this was larger than 0, we'd be even more wrong. Start to end 3959. Well, there's something a little bit cheesy I can do. Since this is a debugger here, it's not the prettiest way to track this down, but it'll work since this is going to be recreatable. There we go. Let me just make sure it breaks right afterwards. It does. Still run that again. I just tested that it was going to break so that I didn't end up like having two different cases where it got to that particular value by chance, and the first time it works and the second time it breaks. So just making sure the first time was the one where it would break. Okay. So O size is 3964, which is basically the sum of these two guys, 3576 and 338. So let me put all of these up there for me to watch. .3964 is not less than that. Start 3959 is greater than this, so it's going to move start minus size 1. Wait, does that make sense? Yeah, because size start is greater than size 1, so we're moving everything to the left in that space of extra text. So after that we have 3959 and 5. Sorry again if you hear any random background noises. Sounds like my dog's excited today. Let's see, so now it's going to copy into that location nothing at all, which is okay. End plus gap size. It's pretty big. I wonder if that adds up to 3959 is where this starts, right? Where does it end? 3964. So 3964 is where it ends. That would be size 2 plus that, right? So that's the original size. It's deleting all of size 2. So that should go to 0. How is it starting at 3959 and ending at 3964 if the shift amount is -16? Oh, it calculated... Why did I end up moving this down? I don't remember. That definitely has to come first. I might have two different cases where I'm using shift amount and I calculate it like I need shift amount to be after this computation here, but maybe some other use of shift amount needs it before that computation, so I need both versions, and that's why I made that move. 4555 or 455. So that should go there because that makes sure that I'm calculating the correct shift amount for this one gap buffer. But do I ever use shift amount later on and mean the full shift amount? I don't think so. I don't totally understand. What do you do that for? What do you do me that way for? Visual Studio. Okay. I'm gonna run this real quick to see. Turn off my breakpoint. Turn off yesterday's breakpoints permanently. I'm gonna run the stress tester real quick. So that's causing that to break again. So the total size, the buffer size variable is not updated correctly now. Why is that? And I'm betting that that is a result of the move that I made of that if to down here. I don't think it was doing that earlier today. I'll check just for sanity. Yeah, so that does make the whole difference. So there's one piece of code that wants shift amount calculated before end gets updated, and another part that wants it after. So I need to figure out which piece of code that is that cares about that. That wants the shift amount coming after or before, and change it. So shift amount. I'll bet you this one right here. What does it want? I don't know. Gap size. None of these should affect the buffer size directly, right? So it's very weird that they do. I'm not sure how they do, because the buffer size gets computed here, right? And then never again. Maybe the buffer size is computed correctly, but the loop there that computes total size is wrong because like these got wrong somehow and this got wrong somehow. Like maybe that's what's going on. So I'm gonna take a look and see. Yeah, so that is hard to say for sure if that's right or wrong. Let me look at the gaps real quick, see if I can get any clues there. How many are there? 5. Interesting. Here's a loop over all of the gaps. Start position. I should assert right here at the end. Local start position plus equals all that. So each time your start position gets set. And then what I could do is I could say debug, update the start position one more time. And then assert that this is exactly equal to the buffer size. Okay, cool. So that confirmed my theory that it was happening right there. The buffer size is 9621, which is probably exactly what happens if you take local start position minus gap size 2. 9621. Very interesting. So does that mean that it's adding in an extra amount of text into the buffer that it doesn't need to? And what would be causing that? Interesting. So really I need to move those around. That's the bug. Right, so I'll update these by their start position first. I'll make them relative. Then I can check if the end is larger than it should be still, and fix it there. And here I can also just like assert that these are both greater than or equal to 0. See if that does it. Oh, okay. Okay, this is working now. At least so far. Yeah, so that worked. And now, what about the white space clean? Control Shift tilde. Still something isn't right. And are we right back to where we started, I wonder? It's different now. Alright, so let's look at these new variables. O size. Wait, no, shift amount. So we're decreasing by 16 if everything is done correctly. Size 1 and size 2. it's only subtracting 5. Now, the shift amount is being computed after end was capped, right? 162, 3, yeah, so end was definitely... So how is it that this is 16? I'm not sure. Well, I'm going to turn this back on and change the condition to be when... Wait, let me put those variables right here. Just again to hope that I can catch it right when this particular case is about to occur. 162 and end equals 178. Okay. So the first time through, since this is a little bit of a cheese, I'll make sure that it breaks right after this without walking through. Okay, slowly. Okay, now I go through it slowly, since I know that that is in fact the one that's going to cause it to break. So, start and end, what's my shift amount? Negative 16. How is that? 0 minus 178. So 178 minus start should be... Yep, and that's fine, because these two here have... definitely contain that... that whole range. So original size is 4085. End is not less than size 1. Start is not greater than size 1. Oh wait, is it? 62. Oh wait, yeah it is. Okay. And so then it figures out how much it's taking out, which is 162, and moves this all over to the left, increases and decreases those two. And they still add up to 4085, I'm sure. Cool. So next, you copy into there the new string, which is nothing. Right, so nothing actually happens there. The new size 2, what will that be? Well, we moved stuff to the left, and the part we moved was everything we weren't going to delete, right? Start minus size 1, what would that do? Yeah, so everything we're not going to delete got moved to the left. So, like, size 1 shouldn't change at all, which it won't. And all that's left is size 2, which should decrease by 16. But the question is, the distance between those is 16. Right, we already confirmed that, so when this goes, it's... Oh, is that full size? Yeah, that's full size. 8192 minus end plus gap size. What is the gap size? 4096. $42.74. So 8192 minus 42.74 is 3918, and that isn't enough. It should have subtracted. It should have gone down by 16, and it's not doing that. It's only going down by 5. I'm not sure that this logic makes any sense. I think at one point I was confused by what I needed to do here, and I said it did make sense, but I kept it. And now I'm looking at it again and it's not making sense. This is the whole buffer. I want to figure out if I know how big my gap is. Oh, I should probably use the gap size after I've changed it, right? I should use the gap size after the shift, maybe. I'm not sure. It's hard to say. Felon Pro 100, yes, this is C++. Also welcome to the stream. This is the gap size before the shift has happened, so it's like, let me draw a picture of this because I can't quite do it right now in my head. Here's the whole thing, start, end, and the gap in the middle. I moved over here some stuff that I'm not going to delete. And then, well, just the general case would be, I have some stuff here that I'm deleting, and I have some stuff here that I'm deleting. And the size of this just becomes whatever position this is, so that's correct. The size of this should be, if this is the end position, the new size of this is the old size of this minus this amount. What is that amount there? That amount is E minus size 1 plus gap, right? E minus size 1 plus gap would give me this. Call it A. And then size 2 prime, the new size 2 equals size 2 equals old size 2 minus A, which is old size 2 minus E plus S1, whoops, not 2-1, S1 plus G. Does that make some sense? I want my new size 2 to be whatever my old size 2 was, plus all of this. Well, all of that there adds up to the whole thing, and then just minus the end number? Oh! That makes some sense. Wow, okay. So, Felon Pro, I can't explain all of it. I've been working on it for a while, but what I can do is I can refer you to here. This is where all the code is available, and you can look at my work on, if you look through old commits, you can go all the way down to day 1 and look at like the first thing I did and so on. So that would be a good way for you to like get into what all of this code is, and it's all public domain, so you can like look around it and play with it and stuff. But the main idea is that it's a multi-gap buffer. So the idea is I have text that I'm storing for a text editor, and some of it's stored in this side of the buffer, some of it's stored in this side, and in a multi-gap buffer there's a bunch of chunks that each one makes up a gap buffer. So there's like, here's some text, here's some text, here's some text, here's some text, so on and so on. And I'm working on an issue right now where once in a while it's doing some inserts and it doesn't compute the size of the whole thing correctly. Like somehow one of the sizes gets off. And I think I'm about to narrow it down because the issue is this right hand side. I have to figure out the size of that chunk. And I know the size here, right? If this is 0 right here, I know this value. So it should just be this value minus this value. And this value here is the end value, which should be the size of this gap plus my end, which is what I'm doing, right? So it seems like it should work. Seems like it should work. Size 2, yeah, not that one, this one. Right? No, I'm too far down. This one, yeah, this one right here. The whole size minus this port. It seems like that should work. But when I run through there, I come up with the wrong value. I'll show you a demonstration real quick. So I pull up in my text editor. It's color highlighted right now to show me where those chunks are. So here's the left-hand chunk of a chunk, here's the right-hand part of a chunk, and then here's the left-hand part of the next chunk, etc. So I can see those chunks. And this tab right here, which is marked with a /T, I'm going to use my white space cleaner, which cleans all the white space, which means one thing it does is replace tabs with 4 spaces. And it leads to this point where there's a bug. It's not a console application, it's a graphical application that does all of its rendering itself. So I'm moving 162 over to the left, right? And that works. And so that still adds up to O size. Then the problem becomes that this amount here is 4274. Hello Manta Gaming, hello Zad Attacker. If you want to see what I'm working on, the main description is in Twitch below my video. If you're not on Twitch, I'll point you in the right direction. There's this 4coder.net, and I went to /4coder just now, which is the blog. You can also get some info on the info page. This is all about what I'm working on. And then right now I'm working on a buffer experiment, which is all public domain stuff. So if you want to check out some of the code I'm working on, I update it every day until I'm done, which should be in the next week or two, hopefully. And you can check it out there. I posted the link in the chat. And at this very minute, I'm debugging an issue with the MuGaB buffer. The last issue, hopefully, that I have to deal with, because it seems like everything is pretty solid. Just this one little thing has to work out. And I'm pretty sure that will be the last of the stuff I can test with my current system. So the issue is one end plus gap size is 4274. And that's only a decrease of 5. 3923. So for one thing, we moved a bunch of stuff over to the left. How would it know? Well, let me think about it this way. Gap size is 162. Or size 1 is. The gap size is 4096. And size 2 is 3923. That doesn't add up. I don't think that adds up. 8192. Whoa, that's weird. So I've somehow lost my other 5 points. Okay, I need to run this again because I've just made it an unusual discovery. So what I'm trying to do is make the white space cleaner work when I do Control-Shift-tilde. It comes through here where the bug starts. And what is the sum of gap size 1 plus gap size 2 plus gap size? All of those should always add up to this, and they don't. Wow. So how did that happen? So now it makes sense to me why there's a problem, because somehow these don't add up. But I'm not sure how that would have ever happened. It's really weird. It got messed up in a previous edit is what happened. So this is all irrelevant. That got messed up in a previous step, which means none of this is going to help me. And what I need to start doing is saying, right here I'm going to do a check on the gap buffer, at least for now, to figure out what's going on. 633. Right. Okay, again, clean the white space. Where does it first catch me now? Right here during the edit step, when I is 37, something goes wrong. So now we have a way to stop before something goes wrong and watch it happen. Okay, go in there. Okay. -16 is a pretty common shift amount with this operation. Grab all of the gaps. Starting at 2, ending at 3. Interesting. So that'll be an interesting case that doesn't come up all the time. If edit stage is 0, which it is, increase this by, or decrease in this case, by the shift amount. Do a loop over existing gaps. How many are there, huh? 26, quite a few. So get to the bottom of that. And then think that's just totally wrong. So planted gaps should come out to be 0, which means that should be a -1, not a start 1. I think most places I do -1 with this logic. Well, here I was copying that. I think there should like be parentheses around there is the other way to think about that logically. But I think the best way to think about it is to put the -1 there instead of the +1. Okay, let's see if that works at all. Trick with this code is there's just a lot of branches it can go down, so it takes a lot to test every branch. Like this stressor here that I was doing yesterday doesn't actually test that branch at all because it never inserts in the middle. So although it does a great job of making sure that I can grow the buffer and I can start from empty and do all sorts of tough stuff, it only tests about half of the corner cases. But luckily white space batch editing is also testing a lot of stuff. Okay, so this comes in here. We skip down to this part. And it goes, okay, nothing is supplanted. Chunk max, yeah, we have some free space for decreasing chunk count and moving free gaps over. Hello John W71, welcome to the stream. Just gonna do a little bit of work moving 0 gaps over. And then mem moving gaps plus gap into gap. Yeah, like none of this needs to happen if gap start is exactly less than, like, this part here is the part that needs to happen if that happens. Welcome back, Felon Pro. Hello again. So local end is 11. And it does some work to remove that from gap, which is equal to, okay. So size 1 is greater than local end. It is not. It is. Oh, it is. Duh. Okay. Other way around. I always seem to flip those today. Which one is which when I'm doing a greater than in my head. Kind of a weird thing. Size 2 just went haywire. I think this code is maybe flip-flopped. Phone Pro 100, I started off with, I did some console applications, but just sort of experimenting a bit, and then I jumped into doing graphical applications pretty early once I was learning C++. Before I learned C++ though, I spent a lot of time using GameMaker. I spent like 2 years on GameMaker before I started learning C++, but I didn't spend too much time on just making console applications. I did spend about like maybe half a year when I was first learning C++ using console applications to do like well, actually, to be fair, it's like a year, because I spent half a year doing like evolution simulations, and then I spent half a year doing like trying to optimize the matrix multiplication with various techniques, and that took me a while, and that was all console stuff. Okay, so what's happening here is I think these two are flip-flopped. Size 1 is greater than local end. or they just don't make any sense. Definitely seems flip-flopped though. Well, size 1. Yeah, this should be local end is greater than size 1. Do this logic. Otherwise, do this logic. Yeah, that's flip-flopped. Okay, 431. I see you messing me up, moving things around where they shouldn't be. Clean the white space. Let's walk in there. So it sees the gap start is going to be, oh, gotta get through this for loop real quick. Okay. Sees the gap start is less than the gap end, but it doesn't really do anything in any of that stuff, because that all just adds up to 0. Local end is 11, so it does a mem move there, and the size 1 goes down to there. Go back to the previous gap, onto stage 2. This is where we get some potential weirdness, I think. 395. Well, this is unrelated weirdness, but maybe this part just passes. We'll see. Yeah, nothing wrong there. Still something wrong here. So that one is still adding up the wrong way somehow. I suspect that I understand it now. An unrelated bug to the first one that I found, but I think that it has helped me understand, because I saw that it was taking 11 from this first one. So let me go through this again. It comes here and it says, oh, I need to take 11 points out of this one, right? So size 1 ends up decreasing by 11 points. And that right there, oh, I need to update the gap size when this happens, don't I? Yes. Okay, so 439, let's do the update there. Aha, there it is. Okay. Alright, that looks like it was successful. Now it's hard to say for sure that we've caught every problem with this, but that would have caught a lot of them, and it certainly did. So I think that the multi-gap buffer is something I can declare finished. I want to take out this debug code for highlighting chunks now, because it really only applied here, and I'm about to move on to new things. But yeah, that seems to have worked. There's an interesting thing you might think about doing to optimize the batch edits, which is that you can see that it has like caused all of the right hand buffers to get really small, which makes sense, but based on the way I'm doing it. Okay. So that means that the multi-gap buffer is done, and we're not even an hour into the stream. Whew. Neat. Awesome. Well, that means that I have a choice here. I could cut the stream short now, or if people are interested in watching, I could start doing some research into ropes. What do people want? What do you want to watch me doing research? Alright, so research it is. Let's get to it. First of all, what is a good way to do this? Ropes, text, data structure. Alright, let's start with Wikipedia, I guess. Alright, so I see a tree right away, which is fun. Looks like a binary tree with text at the leaves. Let's see, 6, 1, 2, 3, 4, 5, 6. So those numbers there are the lengths of the strings on the nodes. Now what are these nodes doing? That says 2, 1, 6. Okay, 22. 6 plus, let me pull up my calculator here. I have a theory. 6 plus 3 plus 2 plus 4 plus 1 plus 6 is 22. So this 22 here is the sum of all of these. So that's like keeping track of the size of the buffer. And then it looks like this right here is 9, which is 6 plus 3. This right here is 6, which is 2 plus 4. So I think the leaf nodes are summing up the weight of the left-hand side. And that makes sense because that means what I could do is say, hey, I'm looking for the 12th character, and I say 12 is somewhere inside this buffer. Okay, 9 left, so if you're 9 or less, you're going to want to go here, or if you're less than 9, go here, otherwise go here. 12 is not less than 9, so I would go this way. And then it's like subtract 9 from it, so in this part now I'm looking for 3, so I would go left, and 2, so I go here, and there I'd find my thing, right? So I can sort of like, it's not really a binary search, but it's more like compare my current value to the weights on both sides. I've actually made a data structure like this before, similar to this, but I didn't know it was a rope. So that's cool. Okay. What are some operations here? So this is the one I just described, which is indexing, which is an O log n operation. Makes sense. Let's see. I don't really care about those. Okay, what does it take to insert? Insert the string s prime beginning at position I in the string s to form a new string. C1 through CJ I C S prime SI plus 1 through CM. Okay, so to do this, it does a split at the location where it wants to do the insert, and then it concatenates the 3 strings together. Split. Oh, that looks kind of nasty. Okay, so anyways, it does a split, and then it does 2 concatenations. Okay, what does a concatenation look like? Okay, concatenation's pretty easy, isn't it? You just take the 2 nodes and you make a new base node above them, or a new root node above them, and that only leaves the question of how do I do this split, and what does a delete look like? This operation can be done 2 splits and 1 concat, right? So you split into 3 things and then concat the 2 things you want and discard the middle part you don't want. Okay, that seems fair enough. That seems reasonable. So J plus log of n to report the string, find the node U that contains CI and wait. In order traversal of T. It's a little gross, but okay. So, what's going to be tricky about this is how to manage all these nodes, but I think that we can crack it. If we did this multi-gap buffer, we can crack this. So, ropes. Multi-gap buffer. Let's see, today's date is November 3rd. This is the rope. Okay. Okay, for this one I still need all of this. And now we have to figure out how we're going to handle all those nodes. So a node is at least something like a rope node array, maybe. So here's all my nodes, and I have a count and a max on that. And I'll have a rope node struct here, and what I need is something kind of like pointers, or in this case I like to use indices to left, right. I probably need parent, and this is gonna need okay. Now the part that gets a little interesting here is how do they get their text? And I could make like a sub-allocated chunk there that I have a bunch of small strings allocated out of. The thing that's going to be kind of weird here is you'll notice that all of this assumes, like if I do a delete, you once in a while have to be able to take one node and break it up into 2 nodes, right? And then you want those to sort of be separate strings. So I need like a string pool that I can allocate out of for variously sized strings, basically, which I think should be contained within this system. So this would be like string start, string size, and this would have like data, max, and this is where it gets a little weird because it's like I have to have sort of a general purpose allocator type of thing here is the only thing I can think of to use, because they could be any size. I could put a max size on them that would be small enough that I could do more like a refrigerator type thing. That might not be a bad idea. That seems better. Okay, so that's what I'll do. The rope string will know about the rope string next free, and will it let me, will that even compile? We'll find out soon. This will be denoted by a 3. And over here, I need to open, oh, don't freak out, Emacs, it's okay. I'm still here. File view, yes, so this now needs to say buffer experiment scalpel equals 2, else rope buffer. Oh, I didn't name that correctly. Buffer rename 4coder ropes.cdb of 4coder rope buffer.cdb. Okay. Just out of curiosity how my line count is. That's not bad. Back to the rope file. It's the rope buffer. Okay. And now very little, there's no way that this compiles right now, so I won't even bother hoping that it's going to compile, but I want to know if this is going to be an issue. It is, okay. So what I should really start transitioning to is something more like this, I believe. Let's see, so this is where I have like my string data, I'll call it, and then I can have my string count, I think is what I want. And I want a pointer to next free. Alright. And that way I can get a bunch of free rope set up for an empty file, a bunch of free rope strings. And what I also need is like a and if I have 8 bytes at the beginning, and I say like 256 minus 8, so like 256 minus the size of a pointer. Okay. So there I've got a bunch of strings. And they'll just live right here. Okay, so now it wants me to implement a few more functions and it will compile, so I'll get around to doing that. I'll look at my previous one. Instead of the multi-gap, we want the rope buffer. And that won't quite compile because some of this is bogus, but is good if data does not equal 0. I could just say 0 is always the root, and then what I can do is say that the size is the buffer nodes. Right, each of these nodes up here needs a weight, so I know my left, my right, my parent, where my string starts and where the string size is if I'm a leaf. Otherwise, I need to know what is my... Oh wait, I need to know weight anyway, right? Yeah, so what I would actually want is more like boom and then weight, where if you have a string start, if it's or if you, yeah, if this is a valid string start, so as in it's like it's not 0, if 0 won't be a valid string start because inside this buffer here, 0 points to a rope, like the header for a rope string, not for the actual string, so that being 0 is invalid. Basically, if that's 0, you don't have a string. If this is 0, your weight is the weight of the total weight of the left-hand leaves, right? Now, if I'm going to do this properly, I'm going to be able to make that work easily. What I'd like to be able to do is just say, to get the total weight of this, I want to be able to look at if I have some nodes here. Why do I suck at this? If I have some nodes here, Okay, so here's my little rope. I know the weight of each of these, so if it's like, oh, I add up to 5, 3, 10, 7, 4, 8. And I think one big part will be making sure this stays balanced, because that's like a balanced rope will be log n traversal, whereas a horribly imbalanced one will be pretty terrible, right? And then if I look at the weights going up, it becomes a little tricky because it's like 5, 10, 4, but this isn't 15 or 5, it's 5 plus 3 plus 10 plus 7. So it's like I want to keep two values here. 8, 17, and 8 plus 17 would go here, whereas 8 would go here, right? So 8 plus 17 is like 25, and 4 plus 8 would go here, which is 12. This over here on the left hand side, it takes 25, And on the right hand side takes 25 plus 12, which is 37. And so a 37 and a 37 end up over here. That seems pretty good. So the advantage there is I don't have to like traverse all the way down and add everything up when I want to add those guys up. So I actually need two weights. I need the left total, and I need my own total, right? So my left child's total and my total. And that way, if I have a parent, it can get my total just by reading it out of here. And I can always add up my total by taking the total of the two beneath me. Or something like this makes sense, right? So like the total weight here is the 8 plus the 17, but the 8 only lives here, and so on. And the left weight is the one you use for traversing down, but the total there, and then the way you tell whether something, and since these will be used by strings and non-strings, yep. Okay, so that's starting to make a little bit of sense to me. There's still the question of how I'll free nodes if I need to free them. Which is kind of interesting too. I don't know if I want a free list for those. Seems like maybe I would want a free list for those, so I'll say I have a node count and a free node. Free. This right here is like the free rope string, and this right here is like the free node. Okay. Okay. Okay, neat. Alright, so the first thing I have to do is I have to... Oh, I'm being interrupted. Let's see what's going on here. Nope, ignore that. Okay. So, the first thing I need to do is set up a way to initialize these. Internal rope buffer init. Rope buffer init. Whoops, took too much. There we go. Better. It's right here, it just be a rope buffer. Data size, chunk guy. Alright. Now, like I said, a balanced tree will be better than an unbalanced tree. So basically what I want is, I want to look at how much I can store within one rope string width, right? Then I want to say, like this tree here is a little bit silly, I'll ignore it. What I want to say is I've got some total width, and I want to evenly divide it into chunks. How many chunks will I need to divide it into is my first question, right? So this last one's a little bit too small, which I did on purpose, but basically take the total number and divide by, okay. Alright, so some things I'm going to need include node required, or node count, and the number of nodes that I want is equal to the total size of this thing divided by the rope. String width, right? Yep. Insofar as, I don't know what you mean. Insofar as you could keep dividing it by 2 for the two sides of the tree. Not sure I know what you mean. Alright, so that figures out how many nodes I need. And then the next thing I can do to set this up is I'll divide this once I know how many I need. So it's like 1, 2, 3, 4, 5 is the minimum that'll hold it. So if I'm having 5, then what I'll say is, okay, forget that, I have 5, evenly divide those 5 in like so. Whoops. 2, 3, 4. So now I have 5 chunks that are like evenly divided, and they're all a little less than max. And then what I would do is start grouping them, right? So here's, well, how many I need above here is actually kind of an easy formula. If this, I need 5 nodes for the leaves, and then I need 1, 2, 3, 4 more. Now that I just counted, but the basic formula there is I need 1 for, I've done this before, I need 1 less than however many leaves I have, basically. Oh, that's a good idea. So his idea is, instead of doing this, where I'm going to end up with a little bit of lopsidedness, what I could do instead is start with the total size and say, alright, that's too big to fit inside of one node, right? If this is too big to fit inside of one node, I divide by 2 and I say, okay, I'll need 3 nodes and I'll have half as much. Does that fit inside? And if it still doesn't fit inside, divide that by 2 again. Continue dividing until that the number of the size of each node fits. And as I go, add in the new layer. That's what you're saying, right? That seems like a better idea because that'll make a perfectly balanced tree. And the trade-off is it'll have more nodes than mine would have had. The one I was describing would have had fewer nodes, and therefore a little bit of less wasted memory, but I think the balanced tree is really more important. So I like this idea better. So if that's how I'm going to do it, then it's more like I need some iterators and stuff to help, actually. Divided size, and I need a node count, and I need well, that should be all I need, because I can do a trick for computing node count. So then the trick is set divided size to the size and set the node count to equal 1. Times 2 is 3. Right. And then what I'll do is I'll say, look, if the divided size is greater than size, then we can begin this thing where I say, first of all, the node count is now 2. At the very end, I'll decrease the node count by 1. Or what I could do is say I always start with a node count of 2, always decrease by a node count of 1. Okay, that works out even better. And then thus begins the for loop. Yeah, rebalancing the tree seems like it's going to be crazy. I'm not sure how much of that I'll do. It doesn't mention tons of that here. And a lot of these tree structures tend to rely on the hope that they will self-balance at a given typical use, but like, I don't know. Like the concat here, for example, if I took a big tree like this and concatted that on, I'd end up with a pretty unbalanced tree, and rebalancing it would be kind of a pain. Like, you could imagine doing it by just sort of making good choices about where to split something and then reconcat that back in. But, yeah. Okay, so all divided size is greater than the size. While the divided size is greater than the size, do double the node count. And half of the size, right? So it's actually kind of funny because it looks like this, right? Then check and see if divided size is still greater than this, and that shouldn't be size, that should be rope string width, right? So while the divided size won't fit into a rope string, divide the size by 2 and multiply the node count by 2, and then at the end subtract 1 node. Alright, so that figures out the node count, and then I think I don't need a node count variable. I can just use the init structs node count variable. Now the only trouble is that's a round down divided by 2. Do you see the problem there? Like, does that work? I'm not sure. Not sure. If I have a rope width of 100, and someone comes along and says they want to store 201 things, I need 3 leaf nodes for that. And if I divide by 2 once, it'll come up with 100 as the answer, and then it'll fit and say, aha. Right, so I actually need to divide by 2 that rounds up. Okay, so that'll figure out how many nodes I need. There's also the question of how many rope strings I need, and so to answer that question, buffer data, Um, right, so it'll take 1 to store this string, and then if that's too big, it will double this number. Each time, and that just works out. Okay, now the only trick is I don't like there being a for loop there. Can I make the math work out without looping it? Right, because that's the logic I want, but it's not superb because it requires this loop, which is only a log n loop, but I think that it can be closed in a, it can be solved in a closed form way so that it doesn't loop at all. FuCon, yeah, I'm gonna rewrite a lot of it in Jai when it comes out. One of the first things I'll work on though is like when that comes out, when the moment that comes out, it probably won't be a bootstrapped compiler yet. It might be, like, John might just not release the compiler until he also has a version of it written in Jai. And in that case, it would make it even easier for me to go full Jai. But one thing I want to do is I want to embed the compiler into the editor. So that's one thing I really want to do is get that embedded, and then once that's embedded, is all of the native extension stuff through DLLs or through whatever other operating systems do. Once I might have misspoke there. I'm not sure if I said something that was confusing, but the point is, the very first thing I want is I want the compiler embedded in the editor, and I want the native extension stuff, all of the API stuff, to have a Jai version. Alright, so the question here is I have some size s, and I want to get the log base 2 of that. Whoops. Log base 2 of that number, right? Because, like, or not log base 2, actually. What I want is, what is it that I want? I want, well, log base 2 of that number would help, but it's not really the correct thing. I have a total size, and I want to figure out how many times I have to divide by 2 to get to a certain number, right? Alright, let me do it this way. So, S1 equals, or S, I should do it this way, Sn equals S of n minus 1, S of n minus 1 over 2. I want, I know that S0 equals some number, right? And I want to know, for some n, S of I is less than or equal to some minimum or maximum that I'm able to store. my thinking is that what I want is log base 2. I keep wanting to write log as LG. Log base 2 of S over M. That's what I think I want. Because S over M tells me how many nodes there are, right? Like, that'll just right there tell me how many leaves there are. And then I want to figure out how many times I have to divide that by 2 to get down to... It's like reversing the logic, but if I think the other way around, it becomes a little easier, right? So if I have an S that's super long, and I know, like, okay, that is going to require 1, 2, 3, 4, 5, you know, well, I'll say 5, right? That's going to require at least 5 nodes to store all of that. Then the question is, how many times do I have to divide this by 2 to get to a root node, right? So the first time I divide by, and of course it'll get a little messy because this isn't a power of 2, but I think what I could do is say round this up to a power of 2 first. So I only need 5, but you know what, we'll say that we'll take 3 more than we actually want, than what we actually need, and we'll actually end up using all 8. So we'll round up to a power of 2, and then divide by 2 once, divide by 2 twice, divide by 2 3 times, and so then I figure out, okay, so that's 3 steps of the loop is what would have happened. If I had started here and gone down, I would have taken 1, 2, 3 steps to find this. So it seems like what I want to do. Now the question is, can I round up to a power of 2? What is the... Is there a fast way to round up to a power of 2 in constant time? It seems like slightly difficult. If I just take the log base 2 of this, like log base 2 of 4 would give me an answer of 2. So I could take the log base 2 of this number here and round up, is what I'm thinking, right? Because this is 2 here, this out here is 3, so this should be somewhere between these two numbers, a little bit more than 2, right? Like, I should write 2 point some amount. So I'll just oh, is there a fast way with bit twiddling to if there's a really fast way that I can do it with bit twiddling, that'll be even better, because then it's just a matter of figuring out, like if it's 8, then it's, you know, 2, 4, 8. It's just which bit is on. Unsigned int v, compute the next highest power of 2. Interesting. I'm not sure how it works. But that is crazy cool if that works. Like, that's the formula that Insofar has just posted. Is it this one? 32-bit V. Yeah, it's this one right here. So these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 operations, as they say it here, round you up to the nearest power of 2 on a 32-bit integer. Oh, I see what it's doing. I see what it's doing. I mean, I haven't totally figured it out. I'm not going to claim I've totally figured it out, but what it's doing here is it's saying, basically, if you end up with um, a situation where you have a bunch of ones, right? So there's 4 1s, and then here's, or 4 0s, and here's 4 1s. Then the last step says add 1, and then you get a power of 2, right? A power of 2 is always just boom, 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 right? So that is how you know it goes up to a power of 2. The first thing it does is it subtracts 1. So if you started with this, you would have this number, and then all of those ors will still end you up with this number. If you had anything at all bigger than this number, right, if I have a 1 here or a 1 here, when you do the subtract, that 1 will still be there. And so when it's done filling out all the bits, you have 1s spread all the way across. And then when you do the add 1, you get a 1 here, right? So that totally makes sense. That's cool. I like that. And then the only trick is you have to make sure you do enough of these steps to fill all of the previous ones that need to be filled on any given, on whatever width your number is. That is really slick. Let me just steal this and pop it into my math real quick. Pow 2. Pow 32. Yep. That's just the way I think about it most of the time. Now, this isn't going to work so nicely with negative input. I'll just go ahead and make it unsigned since that's what theirs was, and there's not any question about that. That's really cool. Okay, so if I have my input size, and I'll just get rid of all this since now I know a better way to do it, is going to be node count equals div seal size divided by rope string width, right? So that gives me how many nodes that I need at minimum to store all of the string that I'm being passed. And then what I'll do is if init node count equals 0, init node count, whoops, else or I'll just set some sort of like minimum. If it's like less than 4, it's 4. We'll probably do some other stuff here later. Otherwise, as I start to think about what it takes to edit this thing, it seems like a terrible data structure the more I think about it. Anyway, I need to round up power of 2, right? So Now again, that's only a count of these 8 nodes down here. Let me get rid of all this extra crap. Alright, so that's a count of these 8 guys here. Then I need to ask the question, if I what number do I have? Right, if I have 4 or 1, I will have gone to the other branch. So at this point I either have an 8 or more, and I need to know which bit am I on. 1, 2, 3, ... So time for some more bit magic. How do I figure out which bit the 1 is in? Actually, I don't need that. I don't need to know what bit the 1 is in, because what I'm going to do once I have that is I'm going to have to loop over 3 steps to figure something out. I don't need to know that. What I need to know next is if I've got 8 there, how many nodes do I set up above that? And the rule is always, if you have a binary tree that is completely like every non-leaf has a child, there's always n minus 1 up here, right? If there's n nodes down here, there's n minus 1 up here. 1, 2, do, right? So I just have to add that in. So here's how many rope strings I need. That number plus it times 2 minus 1 gives me how many nodes I need. So rope string count equals 4, init dot rope string count equals rope string count times 2 minus 1 init dot node count equals that. Right? Cool. So that seems pretty good. That'll figure out how much of everything I need. Then there's the... This is actually easier to initialize than the gap or the multi-gap buffer, which could stand to have an inline here and here, I would say. Alright, so buffer need more. This basically returns true unless everything is filled, and so this is pretty easy to figure out what I want to do. I say I don't need more, or I do need more unless the buffer data and the buffer nodes are both satisfied. As long as both of them are not null still, right? Then result equals 0. And then the question is just where's that buffer coming from? And it's in the init as well. Buffer equals init buffer. Okay. And this right here should be a rope buffer. Alright, cool. So the next thing it does is it says, okay, if you need memory, how much memory do you need? And then I respond with this function that says if the rope buffer has data, then I want this, otherwise I want this. And if the rope buffer wants data, the amount that I want is the init's node count times the size of the buffer's nodes. Otherwise, it wants the rope string count times the size of the buffers of a the buffer doesn't times the size of a rope string. That's right here could be a rope node, I guess. Okay, not so bad. And then there's how do you provide the page of memory. And that goes like so. It's pretty much the same as this actually, except it's got to expand out like this. This one can go. Let's see, rope, good. Don't need results in around. Instead, if we have data, then the buffer's nodes equals rope node pointer page, and you want to assert that the page size is greater than or equal to the node count times the size of the rope node. This one down here wants to assert that this is the rope string times the rope string count, and there's no result, but the buffer data wants to equal the page. And then I guess I should store, along with all of that, I can just also assert that the nodes equals 0, just to be cool, and then update this to say node count equals the page size divided by the size of this. So if I get more memory than what I asked for, I will be able to do that, take advantage of it. Page size divided by rope string. Okay. Round right. Okay. Shared. If in def round up. Cool. So that's most of the way there. That provides all of the memory, and then I just have to do an end init. But I think I might take a quick break before I do. I'll be right back. Alright, I'm going to cycle the stream real quick, because if I go for another couple hours, I don't want to have one super long video. So I'll be back in just a second.